We just did expanding logarithms with these rules. Notice we can go in the opposite direction. If I had addition on the outside, I could rewrite that as multiplication on the inside. So we're going to take a look at some examples where now we're going to go in the opposite direction, and instead of giving a small thing that we need to make bigger, we're now going to try to take this expanded form, and then we're going to combine it to becoming a single logarithm. So we're going to combine this example into a single logarithm. So when I look at 2 times log of x plus log of y minus 3 minus 1/2 log of z, I need to figure out how can I use these rules. Now what I'm not allowed to do is I'm not allowed to use these two if there's numbers out in front. So if there's any numbers out here, I'm not allowed to do these yet. So anytime there's a number, I need to put that back as an exponent first. So what this becomes is I move the 2 as the exponent, I move this 1/2 as the exponent, so I have log of x squared plus log of y minus 3 minus log of z to the 1/2. Now remember, 1/2 power, that's the same thing as a square root. So if you see square roots, that's the same as a 1/2 power. Now that I have no more coefficients out in front, I can use these rules. So here it says if I have addition on the outside, that becomes multiplication on the inside. So here I can turn that into a multiplication. I have log of x squared times y minus 3 minus log of z to the 1/2. Then if I have subtraction on the outside, I can turn that into division on the inside. So this first part here is going to be on top, and the second part that's being subtracted will be on the bottom. So this will be log of x squared times y minus 3 divided by z to the 1/2 power. And this is my final fully combined logarithm. So take a look at this example. Again, the first thing we have to do is we have to move this exponents up top. So I have natural log, but remember the whole thing is raised to the exponent. So I have 6x, that whole thing is raised to the 9, minus natural log of 3x squared. So if you'd like, you could use your regular rules of exponents and simplify this. So this will be natural log of 6 to the 9th times x to the 9th minus natural log of 3x squared. Now because I have subtraction on the outside, that becomes division on the inside. So I have natural log of 6 to the 9th times x to the 9th divided by 3x squared. And then again, you can use your rules that you know about exponents to simplify this. This would be natural log 6 to the 9th. That's some really, really large number. I'm not sure what that would be. So I have 6 to the 9th, but that's to be divided by 3. And then x to the 9th divided by x squared, you subtract the exponents, and you get x to the 7th. So you could put this into your calculator, 6 to the 9th power divided by 3. It's some number, and that would be your number times x to the 7th. Now over here, if I have log base 3 of x minus log base 3 of y minus log base 3 of z, I'm going to, again, do the division part here. So I get log base 3 of x divided by y minus log base 3 of z. Now I have division, but this might get a little tricky because you have division with division. Let's see what this looks like. So I have log base 3 of x divided by y. Somehow this is now divided by z. But this looks weird, right? You don't like to have division over division. So we're going to use what we know about fractions over fractions and say, if I have a fraction divided by another fraction, I take the reciprocal of the denominator. So I'm going to have on the inside log base 3 of x divided by y. The reciprocal of z is 1 over z. So simplifying this, I get log base 3 of x divided by y z. So notice what's taking place is that if you have negatives in front of these, those are going to appear on the bottom, right? A y and a z had the negatives in front. Those were on the denominator. However, the ones with positives appear on the top. We saw that over here, right? This x term has a positive in front, and this also has a positive with this. Those appear on the top. The ones with the minus appear on the bottom. So that's just a good way to check yourself at the end to see, wait a minute, did things appear on the top of this when they shouldn't have, or are they on the bottom when they should have been on the top? So just a small little thing to check yourself with.